In this video, we're going to look at an algorithm for determining whether two strings are valid anagrams. And people always confuse anagrams and palindromes. So an anagram is a word that has all the same letters as another word and the same counts. So if two words are anagrams, you could kind of shuffle around the letters and get the other word coming out. Whereas a palindrome reads the same forwards and backwards. We'll probably do that in another video. So the example we have here is somewhat Harry Potter inspired. So our first string is Tom Marvolo Riddle, and the second string is I am Lord Voldemort. So in order to determine whether or not these two strings are anagrams, essentially all we need to do is count the occurrences of each letter in this word. And for this example, we're not going to care about uppercase and lowercase. So we could go through this first string, count them all up. Realistically, in terms of efficient implementation, we'd want to use a hash map. We could also do this with a fixed size array. Maybe we'll talk about this in the coding section. And then we would do the same for the second string. And then for each letter in the entire alphabet, we would make sure that the counts are the same. So starting to go through here, we have a T, O, and I'm just doing tallies here. I, A, N. All right, and in this case, they had all the same letters, so we don't really have to worry about checking all the others. We know they're zeros, but we can see that the counts for all the letters that did show up are the same. So these two strings are indeed anagrams. So let's go ahead and look at the code, and we'll see how we can implement this. All right, now that we've looked at the algorithm on the whiteboard, let's actually look at some code. There are really only two tricky things in the implementation here. One is that we needed to implement our own equality check for the hash maps at the end. And there's a little bit of canonicalization going on with respect to capital lowercase letters and the spaces here. So as we did on the whiteboard, we're going to have a hash map for counts of letters from each of the strings. A map keeps track of letter counts for string A, and B map keeps track of letter counts for string B. We go through all the letters in A, insert the lowercase version into the hash map. This insert helper will throw away spaces because for the purposes of this exercise, we are basically ignoring the spaces. String A has 2, string B has 1, 2, 3, but we really only care about letter characters, not necessarily the ASCII characters. After we've inserted all the letters into the two respective hash maps, we then need to just check if the hash maps are equal. There are a couple ways of doing this. The algorithm I have chosen here is we know that two hash maps cannot be equal if the number of keys in the two hash maps are not the same. So if we reach this, then we can immediately return false without checking any of the other values. If they are the same, however, we can just check all the keys of one map against the counts of that same key in the other map. And if these two maps are different, there will be at least one key where the counts are not the same. If we ever encounter that, we can return early false. Otherwise, if we get through checking all the keys in one hash map and these are all identical in the other map, because we know that the lengths are the same, they must have the same values for all their keys, in which case we can return true. So for the two strings in this example, we would find that these are indeed valid anagrams. Hope that helped explain the problem, and looking forward to seeing you all on the next video.